Hey Radical Scientists, this is Mr. Giovanni with another series of problem walkthrough videos as we wrap up not only this unit on forces in motion, but also our year of learning here as a community. Now, as we are wrapping up things, as we are looking at some of the last problems and preparing for our one and only practice, our one and only test, I wanted to be really explicit about the intentionality that I've had as we are looking at more and more maths at the end of the day in this unit. On one hand, I do want us to get that preparation for how physics will normally be assessed in spaces outside of our classroom, but to be also transparent, I'm also have this goal in mind about not only being able to learn how to solve specific problems like we've been doing all year with these videos, but to also support the development of a problem solving strategy that will really center the learning process as a whole. I will be trying to be clear about what type of process that I'm trying to support in some of these example problems, but at the end of the day, what I'm really trying to I think convey is that while it can be pretty overwhelming to look at a lot of physics problems, for example, at the time and be like, I have to learn how to kind of do this problem in this specific way, truly, I ask us to truly take a moment to think about how math can be a tool that at the end of the day we can use to manipulate, right? Different situations with different little variables or circumstances allow us to really think about what is in our current situation and how do we actually use those tools to apply it. And in this case, I hope that we can develop a type of confidence where we're not looking at these problems and feeling overwhelmed about how much do we know, how much will we get done, and just thinking of each problem as an opportunity to test the actual skill of translating, applying some type of equation, and ultimately solving for what we're looking for. At the end of the day, so much of this will be developed with practice. So without further ado, here we go with the very first problem of our series. And here we go with our first practice problem. Now, for your convenience and for clarity, I'm including the assignment that this problem is specifically coming from, just so that you know maybe like what type of place if you want to get more practice for this type of problem. But I also want to challenge us to think about, let's just look at this problem without any context and see if we can even find out our strategy of how to solve these without being told what equations to use. A car traveling at 15 meters per second starts to decelerate steadily. It comes to a complete stop in 10 seconds. What is its acceleration? And here I want to start developing a couple of habits as we begin developing this practice. 1. What are we looking for? This is probably the most important question, only because it tells you where ultimately you need to go, right? What is at stake? And I don't want you to think about the fact that this isn't something known, rather than this is going to be the end of our journey as we kind of solve this problem. Typically, it's good to look into the very last part of that question if it's written out, right? As the question will most likely explicitly ask what you're looking for, and in this case, it's an acceleration. We know in physics we symbolize this with an A, right? And that A is an unknown value. We don't know what it is, and again, this is where we are supposed to ultimately solve. This is where it's going to be the end of our journey, given what we are working with. Second thing to also keep in mind is, of course, what do we know? Very few problems are going to give you nothing to work with, right? Maybe there's some questions where you have to think about things through. More often than not, you will have some very clear values to work with, right? In this case, numbers are often like something to just really off the bat highlight, right? 15 meters per second, 10 seconds, and we can think about everything else afterwards, but these are very clear things to start working with. In this case, a 15 meter per second, that unit is a velocity, so we know there's some type of velocity involved. That's 10 meters per second. And we also know that there is a 10-second value. Seconds is a time. So we can go ahead and write that as something we also know, 10 seconds. Now this is already enough for us to really start working with, right? We have an acceleration that we're looking for, a velocity, and some time. But there is also a kind of hidden value there that we can only really take off thinking about it closely and with a closer read, right? So this car comes to a complete stop in 10 seconds. And where it's like stop, where it's like still, complete stop, right? Are things that are and we can kind of understand as just being in one place. But when we think about its position, right, the fact that it is not moving its position, and the fact that there is no speed at that point, we can also start thinking about how this is another velocity to work with, and specifically because the event is this deceleration, the final velocity, which we'll write as 10 meters per second as an additional value to work with. Okay, so now that I know what I'm looking for, and now that I know what I know, right, what things we're working with, we can kind of now look into the formula for physics sheet, any type of formula that we are given or we can kind of recall on our own, right, to look at what different equations might be relevant for this, right? We don't want to work with too much, especially if we don't know stuff like position. I don't know if I know anything in there about some type of position. I see here there's final initial velocities with an acceleration. Once again, position here, final velocity, initial acceleration, and time. Okay, looks like that one might actually be useful. So let's take a stab at it with this equation here. So I'm going to go ahead and put this for reference here. We're looking for final velocity with initial and acceleration and time. It looks like all of those things are there. Even if I don't know acceleration, I know that's what I'm going to be solving for. So I'm going to go ahead and plug in these values into what I know here, right? Final velocity is 0 meters per second is equal to an initial 15 meters per second plus an acceleration we don't know and a time of 10 seconds. Here, once again, we use the tools of math to basically focus on this A, focus on that missing acceleration, and leave it by itself so that we can have some type of relationship. Because here we are only adding on the right side, let's go ahead and just do something that has to do with adding. In this case, I want to get rid of this 15 meters per second, and I do that by undoing how it is related here with that negative 15 that gives us our 0, because we're subtracting anything on one side of the equation must happen on the other side, and this gives us with a negative, leaves us with negative 15 meters per second equals that 0 we can kind of ignore, a 10 seconds. And once again here, the relation with the A is a multiplication of 10. We divide that even more, which gives us a 1 that can cancel out. On our left side, we know that this is going to divide as a number, right? 15 divided by 10, and also incorporate those different units. This stays a negative 15 by 10. That should give us 1.5 meters, and in this case there are 2 seconds in the denominator. Second squared equals our acceleration, right? This unit tells us that this should be in fact an acceleration. We also know from the problem that this must be a negative acceleration. We're going from a velocity to 0 velocity, so the acceleration must go down. And with these steps in mind, we have now calculated for that acceleration negative 1.5 meters per second squared.